First question. The SI unit of universal gas constant R is. Now we know that PV is equals to nRT. So if I take R on another side, so it gives me PV upon NT. So PV is in joules, N is in mole, and T is in Kelvin. So I got the unit as joule, Kelvin inverse, mole inverse. So correct answer for this question is joule, Kelvin inverse, mole inverse, option C. Moving towards the next question. What are the units of K is equals to 1 upon 4 pi epsilon naught? Now unit of epsilon naught is equals to C square upon Newton meter square. So therefore the unit of K, unit of K is equals to Newton meter square coulomb per coulomb square. Now looking towards the option, we have Newton meter square per coulomb square in option B, and thus the correct answer for this question is option B. Looking towards the next question, E, M, I and G denote energy, mass, angular momentum and gravitational constant respectively. Then the dimension of E L square upon M5 G2 R. So here we know that the dimension of energy is M L square T raised to minus 2. Then we know the dimension of mass is M. We know the dimension of I, angular momentum, is M L square T raised to minus 1. And we know the G, that is gravitational constant. So the dimension of G is M inverse L cube T raised to minus 2. Substituting the dimension of above all quantities in the given formula, that is E I square upon M raised to 5 G raised to 2. So substituting all the values, like E is M L square T raised to minus 2, I square, that is M L2 T raised to minus 1 the whole square, the whole upon M raised to 5, and then G square, that is M minus 1 L cube T raised to minus 2 the whole square. When we solve this out, it comes out to be M0 L0 T0. Now looking towards the option, we have the correct answer is angle, because it does not depend on length, it does not depend on mass, and it does not even depend on time. So it depends only on the angle, which is not mentioned over here in the dimension. Okay, so correct answer for this question is option A, that is angle. Looking towards the next question, while measuring the acceleration due to gravity by simple pendulum, a student makes a positive error of 1% in the length of the pendulum and negative error of 3% in the value of time period. His percentage error in the measurement of G by the relation G is equals to 4 pi square I upon T square will be. Now we know that percentage error in G is percentage error in I plus 2 into percentage error in T, that is time period. So now it is 1% plus 2 into, this is 3%. So the overall value comes out to be 1 plus 3 to the 6, that is 7%. Okay, so correct answer for this question is option C, that is 7%. Moving towards the next question, the length, breadth and thickness of a block are given by length is 12 centimeter, breadth is 6 centimeter and height is 2.45, thickness is 2.45 centimeter. The volume of the block according to the idea of significant figures should be. So we know that first of all the volume is given as length into breadth into thickness, that is 12 into 6 into 2.45, and it comes out to be 176.4 centimeter cube. Now since V is this, if I move this decimal 2-digit here, it turns out to be 1.764 into 10 raised to 2 centimeter cube. Since the minimum number of significant figure is 1 in breadth, hence the volume will also contain only one significant figure. So this 1.764 can be approximately taken as 2 into 10 raised to 2 centimeter cube. Okay, so the the significant figure is present in B, that is only 1, and thus we have converted our whole answer into one significant figure. So correct answer for this question is option B, that is 2 into 10 raised to 2 centimeter cube. Looking at the next question, number of particles is given by n is equals to minus d n2 upon n2 minus n1 upon x2 minus x1. Crossing a unit area perpendicular to x-axis in unit time, where n1 and n2 are the number of particles present per unit volume of the value of x, mean to x2 and x1. Find dimension of d as diffusion constant. So we know that this small n is the number of particles crossing a unit area in unit time, and its dimension is given as L raised to minus 2 T raised to minus 1. So therefore N1 and N2 will be number of particles present per unit volume, that is L. So N1 is equals to N2, the whole dimensions is equals to L, and X1 and X2 is equals to the position. Okay, so now if we rearrange this formula and make it d is equals to n x2 minus x1 the whole upon n2 minus n1. Now substituting the values, that is n is L minus 2 T minus 1, x2 minus x1 will be L, and this n2 minus n1 is position. So it is, this is L cube. So this is L minus 3. Okay. Now, when we solve this out, it comes out to be L2 T raised to minus 1, and thus the correct answer for the dimension of D is M0 L2 T raised to minus 1. That is there in option D, and thus the correct answer for this question is option D. Looking towards the next question, with the usual notations, the following equation is St is equals to u plus half a 2t minus 1. We can derive this equation from the equation of motion, so it is numerically correct. Now here this s of t is the distance travelled in time t seconds, which is given as distance upon time, and the dimension can be written as L t raised to minus 1. Now u over here is the velocity, and it is given as L t raised to minus 1. And the last, half alpha 2t minus 1. Its dimension is given as L t raised to minus 1. As dimension of each term in the given equation are same, that is L t raised to minus 1, L t raised to minus 1 and L t raised to minus 1. Hence equation is dimensionally correct also. So correct answer for this question is both numerically and dimensionally correct. Option C. Moving towards the next question. The speed of light c, gravitation constant g, and the Planck's constant h taken as the fundamental units in a system. The dimension of time in this new system should be. So we know that time is directly proportional to c raised to x, g raised to y, and h raised to z. Therefore, t is equals to kc raised to x, g raised to y, and h raised to z. Putting the dimensions in the above equation, so t is equals to m0, l0, t raised to 1, which is equals to k, that is c, that is l t raised to minus 1 raised to x. Then for g, it is m minus 1 l cube t raised to minus 2, and next h, that is m l2 t raised to minus 1 z. Okay, so m0 l0 t raised to 1 will be equal to m minus y plus z l x plus 3y plus 2z, and t x minus 2y, it's minus x minus 2y minus z. Now comparing all these three powers of m, l and t, we get minus y plus z is equals to 0, x plus 3y plus 2z equals to 0, and minus x minus 2y is 2y minus z is equals to 1. On solving equation 1, 2 and 3, we find out that x is equals to minus 5 upon 2 and y and z both equals to 1 upon 2. So when we put this over here, it is g half, h half and c raised to minus 5 by 2. So correct answer for this question is option A, that is g raised to half, h raised to half and c raised to minus 5 by 2. Moving towards the next question. X is equals to cy z square. Find the dimension of y in MKSA system if x and z are the dimensions of capacity and magnetic field respectively. So we know that y is equals to x upon 3z square, which is equals to m raised to minus 1, l raised to minus 2, t raised to 4, a raised to 2, the whole upon m t raised to minus 2, a raised to minus 1, the whole square. And it comes out to be m raised to minus 3, l raised to minus 2, t raised to 8 and a raised to 4. So correct answer for this question is option D. Moving towards the last question. A wire has mass 0.3 plus minus 0.003 gram, radius is 0.5 plus minus 0.005 mm, and the length is 6 plus 0.06 centimeter. The maximum percentage error in the measurement of its density is. So first of all, we know that density rho is equals to mass upon volume, which is equals to mass upon volume can be written as pi r square L. Now, if we take the difference, that is delta rho upon rho, which is equals to delta m upon m, plus this r square will become 2 delta R upon R plus delta L upon L. Now let's put the values which are given. So we need to find out this delta P upon rho, delta rho upon rho, which is equals to 0.003 upon 0.3 plus 2 into, okay, 2 into delta R given is 0.005 mm, the whole upon 0.5 plus delta L is 0.06 centimeter, the whole upon 6. Now when we solve this out, 0.003 the whole upon 0.3, it comes out to be 0.01 plus here it comes out to be 2 into 0.01, that is 0.02, and for here it comes out to be 0.01. When we add it up together, it gives you 0.04. This is nothing but delta rho upon rho. Now for percentage error, okay, that is delta rho upon rho into 100. It is equals to 0.04 into 100. That is nothing but equals to 4%. So correct answer for this question is option D.